This is Algebra 2 with Trig, Unit 6A and 6B review. This is the non-calculator portion, so put your calculators away. We need to graph these without using a calculator. So this is our exponential. What we're going to do is pick our values coming across. So we can pick numbers on either side of 0. So we have 1 and 2, -1 and -2. We know that when we have a number raised to the 0 power, it's always 1. And when we're raised to the first power, it's always that value, which is the b term. Squared is going to be square the top and square the bottom, which is 1 times 1 and 4 times 4. And then the -1 is going to be the reciprocal, so that's 4. And -2 is going to be the reciprocal squared, so it's going to be 4 times 4, which is 16. So watch your scale. We are doing -1 to 4, -2, 2, 4, 6, 8, 10, 12, 14, 16 would be just off the edge. 0 for x would be up at 1, which is halfway to 2. At 1 we're at a quarter, and at 2 we're at a 16th. So now we can draw in our graph. We can label our graph 1/4 to the x power. We can draw in our asymptote, which is y equals 0. So our domain for our graph, what values of x can you plug into your equation? Any number you want. You're going to get answers that are greater than 0. We have a horizontal asymptote at 0, and the end behavior, as we look to the left, we see that the graph is increasing. And as we look to the right, we see that the graph is approaching 0. Here we have an a value of 2, and we have exponential growth because this fraction is greater than 1. The numerator is bigger than the denominator. So one way we could graph it would be to start out with the parent function. Might be somewhat easier for us. So y equals 4/3 to the x power. We'll do 0, 1, 2, -1, -2. We know at 0 we're going to be at 1. At 1 we're going to be at the b value. 16/9, because you square the top, square the bottom. -1 we're going to do the reciprocal. And then we're going to square the reciprocal, 9/16. Now when we do 2 times that amount, 2 times 4/3 x, we're going to multiply all of those by 2. So this is going to be 18/16. This is going to be 6/4. This will be 2. This would be 8/3. And 32/9. So if we were to plot those out, at -2, we're going to be up just over 1. At -1, we're going to be up at 3/2, so that's 1.5. And we're at 2. 3 goes into 8 twice, with a little bit left over, 2/3, about 6/6. And then this goes in there a full 3 times and a little bit left over. So we can see that the graph is slowly increasing as we come around. 4/3 x. We did not need to use a calculator. Fractions help us because we can square a fraction really easily. We can multiply the top of the fraction really easily. The domain is all real numbers. the range is greater than 0, the asymptote is at 0, and as we look to the left, we see that the graph is approaching 0, and as we look to the right, we see that the graph is going up. Here we would start our equation most likely off with 2 to the x power. So if we did -1, 0, and 1, we'd get 1, we'd get 1/2, and we'd get our b value. This should be 2 to the x power. Now if we make a third row and do -3 times 2 to the x power, we're going to multiply all these by -3. So -3 over 2, -3, and -6. So at -1, we're going to be at -1.5. At 0, we're going to be at -3. And at 1, we're going to be at -6. And that approaches our 0. Then we're going to translate this. We're going to slide this over as an h value of -2 and a k value of 0. So we're just going to go to the left 2. So 1, 2, 1, 2, 1, 2. So that's the graph y equals -3 times 2 x plus 2. This first graph was y equals 2 to the x. We had a -3 in front of this one actually. -3, 2 to the x. We would have a horizontal asymptote still at 0. Our domain is all real numbers. Our range is less than 0 because it's down. Our end behavior, as we look to the left, the graph is approaching 0, and as we look to the right, the graph is going downwards. We have a reflection over the x-axis because of the negative, and we have a vertical stretch by factor of 3, and we're translated 2 to the left. So for this one, we're going to start out with 1/3 to the x power. -1, 0, and 1 gives us 1/3, 1, and 3. There is no stretch, no reflection, just a translation. So pretty simple with this one also. -1, we're up at 3. 0, we're up at 1. 1, we're at 1/3. And if you just want to play with 2 also, 2 would be 1/9, but -2 would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that just gives us a good idea of where we should be crossing, more accurate. So now we're going to translate this to the right 2 and up 1. That gives us a horizontal asymptote at the k value, which is y equals 1. We have an equation of y equals 1/3 x minus 2, and our original graph was 1/3 to the x power. Our range is greater than our k value, which is greater than 1. And behavior, the graph is going upwards, and as x moves to the right, we know it approaches the k value, which is 1. The only comparison, the only transformation that it has is a translation. Two right and one up. So here we're going to talk about what do we have. I see two y values. I see a vertex. So it looks like this is going to be exponential. Not exponential, it's going to be quadratic. So we're going to write this in vertex form. Y equals, I go over 1. From my vertex, I am going up 3. So what I'm trying to identify is what the a value would be. Well, what would be the proper way to do this? Proper way would be to solve for it. So I'm going to place -2 for my y, calculate my a. My x is going to be 0 minus my vertex, so minus 1 squared plus k. So add that across, gives me a 3. Square it, so a equals 3. So y equals 3x minus 1 squared minus 5. You ever have a concern, you could type that into your calculator to verify the table. This is a non-calculator portion of the test, so it won't be available during the test, but it is available for your practice. Alright, this one, I don't see the same y's happening, but I see that it's getting smaller each time. It looks like we're going down, dividing by 4, dividing by 4. So if I take, no, not going to use a calculator, so we're going to multiply by 1/4, multiply by 1/4, multiply by 1/4, that would be 6/4, which is 3 over 2, multiply by 1/4, which would be 3 over 8. So perfect. Our b value is a 4. At 0, our a value is 6. So this is exponential, and its b value is less than 1, but greater than 0, so it's decay. So where y equals our a value, 1 over 4 to the x power. It looks like I'm timesing by 5 and timesing by 5, and it looks like I just keep timesing by 5 each time. So my a value would be, this would be dividing by 5 and dividing by 5 and dividing by 5, so at 0 would be at 2. Divide that by 5, keep working backwards. 5 times 2 is 10. So at a value is 2, the b value is 5. This is exponential growth because the b value is greater than 1. So the a value is 2, my b value is 5 to the x power. This time I don't see my numbers changing very quickly. And I look at my x's and they're changing funny also. This is going up by 4. This went down by 3. This went up by 4 again. This went down by 3. Up by 4. This went down by 3. So it looks like I have a slope of rise over run, -3 over 4. So this looks linear. So my slope is -3/4 x plus b, which is 17. Evaluate the logarithm. So this is saying 10 to what power? So 10 to what power equals 10,000? There are 4 zeros, so x would have to be 4. This is 10 to what power equals 1. Any number equal to 1 is going to have an exponent of 0. This is 6 to what power equals 216. That's going to be 3. This is 3x equals -27. Well, notice there's a fraction on one side but not on the other. I know I'm going to have a negative. That's what makes the fraction. And then 3 to the 3rd power is 27. This is 81 to the x power. Remember, a logarithm equals the exponent. So if I could take the square root of 81, I would get 9. So the value would have to be a half. That's one way to do it. The other way to do it is to think about 9 squared to the x power has to equal 9 to the 1st power. So 2x has to equal 1. And when you divide by 2, you get x equaling a half. We have a half to the x power equals 16. So notice there's a fraction on one side and not a fraction on the other. So we'd need a negative exponent, and 2 to the 4th power is 16. So half to what power equals 16? So this is 5 to what power equals 625? Well, I know 625 is 25 times 25, so that takes 4 5s to get there. 16 to what power equals 1/4? I know it has to be a fraction, so I could write this again as 4 squared with an exponent of x, and this would be 4 to the -1. So this is going to be 2x equals -1, and x equals -1/2. E, when you're multiplying, you add exponents. So we get -2x plus 4, or 4 minus 2x, however you want to say it. We can divide in to get 6 and then subtract exponents to get 6e to the 3rd. We can take the square root of 16, and we know that e to the 2x and e to the 2x, actually 3x, huh? So 4 squared, we're taking the square root, so we're looking for things that are squared. So the 16, the square root of 16 is 4. And if you look, when you multiply the e's, you add the exponent. So to get 6, I need to break it up into 2 equal amounts. It's 3x and 3x. So I know I can pull out a 3x also. And those would have to be multiplied together to give us 12x. If the bases match, then the answer is x. if we can make these match, so 5 to the third power, if those match, then our answer is 3x. On our final side, to graph a logarithm, we're going to look at the base to the exponent. You know, a logarithm always equals the exponent, equals x. We like to pick our y values, so -1, 0, and 1. So an exponent of -1 is going to be the reciprocal. 0 is always going to be 1, and 1 is always going to be that b value. So when x is 2, we're at -1. When x is 1, we're at 0. We can try it again if we wanted to, and we could plug in a -2, which would give us 4. 1, 2, 3, 4, we're out at -2. So that just helps us know where we're supposed to go through with the graph. So don't worry about trying to grow that graph a little bit extra. So this is y equals log to the 1/2 x. We know the asymptote is going to be vertical at x equals 0. We can have a domain that's greater than 0 and a range of all real numbers. And as x goes to the right, the graph goes down. Here's our logarithm. We're going to first work with logarithm of log base 3 of x, which is going to be 3 to the y power equals x. Pick our y values, calculate our x values. Here's our reciprocal, 1, and our b value. When x is 2, we're out at 9, just to kind of grow it a little bit further. So when x is small, we're at -1, 0. That's 3, 4, 5, 6, 7, 8, 9. We're up at 2. So that gives us an idea of where this line should come through. We have a vertical asymptote. We're not going to draw that quite yet, though. Sorry. We're going to wait for the final graph. Now we're going to translate that graph to the right and 1 up. To the right and 1 up. To the right, 1 up. To the right and 1 up. So this is the graph y equals log base 3 of x minus 2 plus 1. And this first one was y equals log base 3 of x. We know that the asymptote would now be out at x equals the h value, which is x equals 2. We are greater than 2 for the domain, and we're all real numbers. We're going to approach 2, because that's the furthest to the left we can go. The y value is going to -infinity. And as x goes to the right, go forever to the right, the graph goes up. Here we need to talk about exponential growth and decay. So here we know that the a value is greater than 0 and the b value is greater than 1. So we have exponential growth. Here we have an a value greater than 0 and we have a b value between 0 and 1. That's exponential decay. Here we have an a value greater than 0 and an r value less than 1, or less than 0. So this is going to be exponential decay. Because the r value, you can look up here, the x value is next to the r. The r value is negative, so it's going to drop. So I'm expecting this graph to look something like that. It'll probably cross up pretty high, up at 63, but it's still going to drop. Here we have the a value that's less than 0. We can stop right there. This is neither. This would be reflected over the x-axis. This here, the a value is less than 0. We can stop right there. And this is going to be neither. And here, this would increase. If the negative decreases, we have an a value greater than 0 and an r value greater than 0. We get exponential growth. We made it.